Hello, Algebra 2s. Would you like to do my key with me for 6-5? All right, number one, the first thing we're always going to do first is factor, because we want to see any common values in the numerator and denominator that we can cancel. So when I look here, I have my 3 and my x squareds, and I pull out a 3 and an x from the denominator. Oops, forgot my x. And an x from my denominator, leaving me with an x squared and a 7. This is the sum of x squared and something that's not a perfect square, so it's prime. And here, this 3 cancels out with this, and this x cancels out with one of those x's, leaving me with x in the numerator and x squared plus 7 in the denominator. Those parentheses are not necessary, they're just there for clarity. All right, let's check out this one. I know right away that my denominator is going to factor into x plus 2 and x minus 2, because I see the difference of two perfect squares. Don't be freaked out about that 4 there. What you're going to do is just evenly split them up. So 2x is here and 2x is there. And I know that they split up that way because I look at my middle term. So I have a negative product. So one's a plus, one's a minus. My sum is a negative, so I have more negatives than positives. Nothing cancels out. Oh, sure it does. There we go. This was x to the 4th. So now I have x squared minus 6 over x squared minus 2. Nothing else cancels out. Those are algebraic expressions protected by the parentheses. Okay. Number 3. So we'll go ahead and rewrite our numerator. That is simplified. And if it makes you feel better, go ahead, bubble wrap them. I have the difference of two cubes, so I have a binomial and a trinomial. Same sign, opposite, always positive. Here's the square, here's their product, and here's the square. When my numerator cancels out, that leaves me with 1 in the numerator. So I have x squared plus 3x plus 9. This is always prime. The trinomial part of the difference of two perfect cubes is prime. So I know I'm done. All right, we'll come over here, and when I go to factor my numerator, I'll see if I can split my x's. A positive sign means that they match. A negative sum means they're both negative. Minus 9, minus 1. When I pull out an x, I get x plus 10. Guess what? That's finished. There's no common factors, no more ways to break it down, and I'm done. All right, next problem. I'll take out an x squared, and that's going to leave me with 3 minus x squared over, I'll take out a 2 and then x squared. That's going to leave me with x minus 3. If I were to take out a negative here, that would make this negative and this positive, so I can rewrite it as negative x squared and x squared minus 3. When I pull this out, I have my 2x squareds and I have my x minus 3. So this is tempting, but not an option, and I'll go back up here and make sure that I did everything right. The only thing that could be canceled out here is my x squareds. So in the end, I have the negative outside, x squared minus 3, and x minus 3. Nothing else can be canceled out. We pull that negative out because we want to leave things in standard form with our x's first. Okay, so we'll take a look at this next one. And I'll go ahead and I'll draw my parentheses. And I'll split my x's. The negative, so 1's plus, 1's minus. More negatives, so the 3 and the 2 of my factors goes there. I'll do the same thing here. And I'll split my x squareds. I have a negative, so 1 is going to be positive, 1 is going to be negative. 36, when I look at the factors of 36, I have 1 and 36, 2 and 18, 3 and 12, 4 and 9. Here we go, that one is the one with a difference of 5. My 9 is going to be negative, because I have more negatives than positives. My 4 is here, and right away I recognize the difference of two perfect squares. So I'll go ahead and I'll cancel out those x minus 3's. So my final answer is going to be x plus 2 in the numerator. In the denominator, I have x squared plus 4 and x plus 3. That's what's left for that one. All right, so even though these look different, they're actually the same, because multiplying fractions is no problem. Top times top, bottom times bottom. So I'll go ahead and just pretend like all these are in one big numerator and that all of these are being multiplied. I'll bubble wrap things just to make sure I remember the algebraic expressions cannot be canceled unless they are identical bubbles. All right, let's factor this one. A 4 and an x come out. That leaves an x minus 1. We'll go ahead and draw my parentheses, split my x's. Minus 6, and so I have 1 plus and 1 minus. I've got more positives than negatives, so we'll divide 3 and 2 out that way. I'm going to move this 4x up here because then I know that they're going to cancel out nice and cleanly like that. And I'll go ahead and I'll put x squared, 1 positive, 1 negative because of that sign. The bigger number is positive, the smaller number is negative. This is the difference of two perfect squares, so I'll have x plus 1 and x minus 1. That goes there. Squared plus 3, x minus 1. That's the fun part, seeing which expressions are identical and can be canceled out. X squared minus 2 is in the numerator, and x plus 1 is in the denominator. We'll go ahead and box that. Okay. We'll go ahead and multiply fractions, is no problem. Top times top, bottom times bottom. I don't see any plus or minus signs, so this one's actually pretty straightforward. Anything in the numerator that matches the denominator can be canceled out. Now, some people think it might be easier. I'm not going to bother multiplying because I'm just going to be canceling out. But it might be easier if you tally up how many x's you have as factors and how many y's you have as factors. Move your coefficients to the front. And then, again, the tallying of the x's and the tallying of the y's makes it easier to do your crossing out. Okay, so I have 30 and 10, so I know that's going to simplify to 3 halves. And I know I have 4 x's in the numerator, because this 1x will cross off with one of those x's. These 3 y's are going to cancel out with 3 of these. and that's just going to leave me with 1y in the denominator. Okay, let's take a look at the back. We'll go ahead and put these in the multiplying fractions is no problem, top times top. Bottom times bottom, my y squareds cancel out, and my result is 1 over x. Don't you wish they were all that simple? All right, so when we're talking about division, we want to rewrite it so that we are multiplying by the reciprocal. So this fraction stays the same, 15x y squared, and it's going to be times 5x y to the 4th over 2x cubed. So division becomes multiplication, and then of course I get the same value. I don't change the value of my numbers when I multiply by the reciprocal. All right, so we'll do the same thing. We'll rewrite everything by grouping our exponents. So we'll leave 8 and 5 as coefficients, but I see here I've got 3 x's and 5 y's. So 15 and 2. That looks like 4 x's and 2 y's. So my 15 and this 5 is going to leave me with a 3 here, and this 2 is going to leave me with a 4. So my fraction has coefficients of 4/3. I have 1x left in the denominator and 3 y's in the numerator. So 4y cubed in the numerator. All right, let's see here. Rewrite my first fraction, x minus 2 and x plus 1. Remember, these are bubble wrapped. Times x plus 1 over x plus 4. Lovely. I'm left with x minus 2 in my numerator and x plus 4 in my denominator. Right, so we'll go ahead and factor. X squared, split those 4 x's up. Minus 6 is going to be, let's see, minus 6 and plus 1, because I have a negative product, plus and minus. More negatives than positives. This 4x to the 5th will just stay there. No need to flip this because it's multiplication. Nothing to factor here. Let's see if we have more luck down here. We'll go ahead and split my x squareds. Plus 1 plus 2 is going to give me a sum of 3. So these two can be canceled. Those two can be canceled. So what I'm left with is x squared minus 6. 6 is not a perfect square, so that's not anything I can factor, even though x is squared and it's a difference. So that's all I have. Alright, the sum of cubes. So when I do the sum of cubes, we'll go ahead and say x plus 2 is my binomial part. X squared plus 2x plus 4 is my trinomial part. So same sign, opposite sign, always positive. And here's my a and b, my a squared, my b squared, and then a times b. Underneath is x plus 1. I can just continue these are multiplied. So I have a difference of two perfect squares, x plus 1 and x minus 1. And here I have x plus 2 and x plus 2. This is the square double square pattern, giving me perfect squares. All right, this is canceling with that. And one of these will cancel with that. So in my numerator, I have x squared minus 2x plus 4, which is always prime, x minus 1, and one of my x plus 2's. All right, moving on. Go ahead and multiply, bubble wrap these. And I know that I have x and x, let's see, 48. Signs match, they're both negative. 6 times 8 is 48, so we'll go ahead and put 6 and 8 there. Down here we'll pull out an x, and we'll have x minus 6. We'll also pull out a 3, and that's going to give us x minus 8. So that those cancel out. 1 will hold the spot for me, and 3x is in my denominator. Alright, so we'll go ahead and put this over 1, if that's easier for you. Bubble wrap it. We're going to multiply by the reciprocal. So x plus 5 comes to the numerator. We'll factor this. That's the difference of two perfect squares. 2x plus 3 and 2x minus 3. So we can see that these will cancel out. And I'll have x plus 5 over 2x plus 3. Last one, so 2x, there's nothing to factor there. We're going to multiply by this value there, which I'll go ahead and factor. So if I have positive, the signs match. Here they're both negative. So that looks like 4 and 2. So in my denominator, 3x, oops, I can factor that. If I take a 3, that leaves me with an x minus 4. And remember, this is now in my denominator. These are what I'm switching because I'm multiplying. I'll pull out an x, and that's going to leave me with an x minus 2. All right, so we'll go ahead and cancel out things that are the same above and below. X minus 2 and x minus 2. X and x. X minus 4 and x minus 4. So this simplifies to 2/3. All right. Hey, look at this. You have a mini quiz. Next class, make sure you study.